Welcome back, Franken friends. I'm Greg Smith, aka Dr. Frankentosh, and today we're talking about GTOS, the real-time operating system I built to run the iBookintosh project. So GTOS is built on top of Goop, which is the object-oriented programming environment I created to program in C, and we'll talk more about that right after this. Welcome back. I want to give my usual disclaimer, which I often give at the end. I'll give it up front. Please don't like this video. Don't subscribe to my channel. Don't click up there or down there. Don't watch my other channels. Your time is precious. Thank you so much for spending part of it with me. Now let's get started. So if this is the first time visiting me and you haven't been up to date on the iBookintosh project, what I'm trying to do is take a iBook from 2000 and remove the insides and replace the processor with an M1 MacBook Air processor. But I want to keep as much of the original parts as I can, and that includes the case, the keyboard, the trackpad, the display, and potentially the CD-ROM. So that's kind of a big order. Now, I had originally started this project thinking about using the Teensy processor and Frank Adams keyboard code. The challenge I had there was that it was not designed around the Raspberry Pi Pico, which is my weapon of choice. So I started looking at porting the code over and using Python. Python was too slow for all of the multitasking I wanted to do. So I stepped back and started thinking about what kind of an architecture would it take to build something that would drive the keyboard, read the CD-ROM, manage the trackpad and the display, and I realized I was going to need a real-time operating system. There are lots of choices in terms of the real-time operating system. The biggest one for the Pico is FreeRTOS, which I have some small experience with from my academic days, and I decided against using that. I also wanted an object-oriented programming language. I tried to look at some C++ as a language I've avoided for a long time. It's very bulky and I find it takes up a lot of resources, so I put that to the side. So that's when I decided to create Goop, the object-oriented programming environment for C. Does not require a transpiler or any external code. It uses only the C preprocessor to create a object-oriented like environment for programming in C. I have videos on that. Also, there are videos on the keyboard efforts that I did to try and get the Teensy to work. That also reminds me that I spent a lot of time trying to decode the serial port on the trackpad that is built into the iBook from 2000, and found out that that was not going to be powerful enough to drive the MacBook Air. So I ended up working with the TPS65, which is a different trackpad. Once again, I needed to be able to handle I2C as well as the GPIO pins, reading rows and columns on the keyboard matrix. All of that combined inspired me to write my own real-time operating system and my own object-oriented language in Raspberry Pi SDK. So that's the overview. Let's get started on what GTOS ended up looking like. So I had some design goals for GTOS. First off, I wanted it to be object-oriented. I found that OOP makes your life easier. It's easier to use objects, to understand what they do, and to extend them. Secondly, I wanted it to be modular. Each package or module is self-contained and may have dependencies, but the dependencies only go in one direction, and we'll talk about that. Third, I wanted it to be reusable. I wanted to be able to not just use it for the iBookintosh project, but I also wanted to be able to build other things with it, and if possible, allow other people to build things with it as well. And then finally, I wanted it to be extensible. So not only do I want to build the iBookintosh project and the pieces, parts that construct it, but I want to be able to extend each of these packages again for other projects and that other people might make use of it. So those are the four big design goals, and I think I achieved all of them. Here is the layered architecture of GTOS. I know that it's in grayscale now as we uncover each of the different layers it will come out in more clear color. At the bottom, we start with the Raspberry Pi Pico hardware. And likewise, the Raspberry Pi Pico SDK is the layer above that gives us access to the hardware. Then the next layer up are GUtils. All of my packages begin with the letter G if they're part of GTOS, and if they're not part of GTOS, they begin with some other letter. But GUtilities are things like time and some string functions and so on. So the next layer up is the Object-Oriented Programming Environment, or GOOP, and I've already demonstrated this in detail in another video. There will be one coming later which will talk about using GOOP and the G-object layer as a user as opposed to just theory. So this is the layer that gives us access to our SDK as if it was an object-oriented programming language. Now there are some parts to your object-oriented environment that include abstractions like collection objects, and that includes the list, maps, queues, matrices, and so on. So that now gives us the ability to create other data structures. There's also a concept of the context. The context is a kind of a collection of objects that you can access by way of their name. We've seen this used in Java and the Spring framework, and so I borrowed that concept for GTOS. On the left, you can see that there are some utilities, INI data, CSV, and matrix. The INI data is to read in INI files. We created a FAT file system. You can see that as the next layer up. The FAT file system also implements streams, which are streams of bytes that can be read. And then we use those to actually read initialization files, CSV files, and matrix files. So these give us the ability to store information and to configure our system without having to recompile it. If we go up one more level, you can see that the FAT file system has both RAM and flash capabilities, and that means that we can use the FAT file system right in the RAM of the Raspberry Pi Pico, and we can also access the flash memory as if it was a file system. And if we go up the next layer, you can see that there's a thumb drive, which is a object which treats the Pico's flash as if it was a thumb drive by way of the USB. So in order to understand that, we'll have to go to the right, and you can see that GTOS, or the Task Real-Time Operating System, is composed of tasks and executive. The task is a small unit of work that is basically checked on every iteration of the executive. The executive is a scheduler which uses a round-robin scheduling, and it checks every single task in the system to see if it has some work to do. A simple example might be if you have a button that you want to click on and cause it to light up an LED. And so the first task is pulled to see if there's a button. If there's no button press, it goes to the next thing until there's no more tasks to look at, and then it iterates through again. When the task for the button press sees that the button is pressed, it will send a message to the LED task, which then will turn the LED on. When the button is released, it sends another message to the LED task, which turns the LED off. And by creating this sort of predecessor-successor relationship with messaging, we have a loosely coupled design that allows us to be more generic about how we process our events. On top of that is GPIO, which manages the general purpose I/O pins on the Raspberry Pi Pico. And then I took advantage of Tiny USB, broke that out into an object-oriented paradigm, as well as button, LED, and external GPIO pins. I used the MCP 23017 chip to extend the GPIO capabilities of the Raspberry Pi Pico, giving 16 more GPIO pins. Now on top of GUSB is GUSB device, and so that is the device class. The USB then is a controller for different types of devices, and I was able to use Tiny USB to implement the media, which is things like thumb drives and reading the flash and so on. HID, which are human interface devices, the mouse and keyboard devices, and finally the console device. So this gives the Pico the ability to communicate down the USB and actually send and receive console I/O. So you can type on the console, you can read the text that comes from the console. Likewise, the USB allows us to send keyboard events and send mouse events. That will go down the USB to the M1 processor from our MacBook Air and allow it to actually manipulate the macOS user interface. I also mentioned earlier that the thumb drive, which is on the left of this, is not part of the multitasking system. That's because it pulls in the media portion of USB and combines that with the FAT file system. Finally, there's a layer on top that combines all of these together into an application, and that's called GApp or GAP. This GAP is an application framework that allows us to treat all of these as services. And so everything from GAP down is combined into the application framework. We only need to create a GAP object to get access to all of these features. The other thing that GAP does for us is that it is configurable by way of .ini files. So you can manipulate or turn on and off each of the elements or each of the services inside of GTOS with an INI file. And likewise, it enables reading CSV files for things like our keyboard, matrix, and so on. Finally, above GAP are applications and examples that are shipped with GTOS, and that includes an actual thumb drive that gives you access to 64K of the flash on the Raspberry Pi Pico for configuration, things like your INI files, your CSV files, your matrix files. Of course, the big application that I'm building is the iBookintosh project. Then on the right, there are some examples. There's the classic Blinky, an LED that blinks, the button example, an actual CLI, which allows you to create a text-based command language interface, and then examples for both how to set up the application framework, the GAP app, and finally the USB app. So one of the other major features of this layered design is that things at the bottom layers do not depend on things above them. And likewise, things at the higher layers depend on things only below them. Also, there's not much interaction going horizontally between modules. So the idea behind these layers is that you stack these up to build more and more higher levels of abstraction that allow you to build bigger and bigger projects. So thanks for taking the time to look at this design. In the coming days and weeks, I'll be creating more videos about each of the individual packages that comprise the GTOS system and how you might be able to use it to build your own applications. Thanks again for spending time with me. I know your time's precious, and GTOS and iBookintosh are projects that are very dear to me, and I'm hoping that down the road, we'll see more and varied projects that come as a result of all of this work. Thanks again, and I'll see you next time on Dr.